All right, so a couple of things here, guys, before we head across to work on the lab. Okay, when we get to the lab, you'll notice that the teacher lab station is a bit crowded, right? And that's because there's chem classes that we're doing a lab today as well, and not all of their stuff is cleaned up yet. Okay, all of our stuff will be on the west side, okay, of the teacher's desk up front. All right, it's all there labeled in little beakers A through K. Okay, everything is in there. Remember that you need to come up and get all of your required materials. They are all on a little lab cart beside the teacher's desk. Okay, you get your depression plate, your conductivity tester, okay, and your pH strips, okay, and have them all ready to go. Okay, make sure that they are all ready to go so that you can come up and get all of your samples. Okay, put in a small amount of sample into each one of those depressions after labeling them with a Jiffy marker. Okay, I'll lay those out as well so you can go A, B, C, D on all of the depressions. Make sure you remember which ones are which. If you spill anything on those letterings, they may come off. Okay, especially since one of the unknowns is ethyl alcohol. Okay. And a number of the other solutions will also take it off when you make them. So you just got to be careful not to overfill anything. Okay, everybody with me there? All right, guys, you gotta. If I say listen up or stop what you're doing or whatever, I need your full and undivided attention over there. Okay, we're in a lab. We have to be very careful. When you first get in, the first thing you are going to do, okay, is go to your lab station, open up the drawers, get a lab apron and a set of safety goggles. Both of those items go on, and they stay on until I tell you it is safe to take them off. Okay, and remember that safety goggles are worn in the over the eyes position, not the forehead protection position. Okay? If I have to ask you more than once to put your goggles over your eyes, I will remove you from the lab. I would rather you don't get the lab done and can see for the rest of your life than finish the lab and be blind. Although I don't know how you would finish the lab blind. Okay? So, let's not have to worry about that. Please keep the goggles over your face at all times. Okay? Any questions on that stuff? All right. So we'll go over there, we'll do the lab, and then we'll come back and I'll talk about the analysis and the conclusion and the rest of that stuff, okay, after the fact. All right? So I'll come around and check your labs here. Okay. When you are assembling this lab report, now that you have all of your data, okay, you need to take that data and you need to decide, okay, what sample is what? So is sample A water? Is sample B cobalt chloride? Okay, that's what you have to figure out. Right? You have to look at all of the observations you have for, let's say, sample A. Right? Look at it and go, okay, well, sample A was a crystalline. I don't remember what it was. Crystalline solid. Okay, that means it's likely ionic. So check things. Did it conduct electricity? If it did, good. Then you know it's an ionic compound. Start looking at other things it might fit with. All right. There's a couple of little hints here that I'm going to give you, okay, for helping you with identification. Okay, ammonium nitrate, Ammonium nitrate, this stuff here tends to be spherical when it's in its crystalline form. It also tends to cool down when put in solution, because that one's usually the one people don't get. Okay, so just keep that in mind when you're looking at your observations, see if anything fit with that. Okay, remember that sample J was already dissolved for you and previously existed as a white crystalline solid, okay, but we can't get it that way. All right, so make sure that you wrote down that it was in fact a white crystalline solid. What you got was already a solution, which means it's highly soluble in water. Okay, I think for the others you ought to be able to figure it out. Things to look for. Okay, look at things like let's say like paraffin here. It starts with carbon. Okay, and has hydrogen in it, but hydrogen is listed second. Is this a molecular compound or an ionic compound? Does it have a metal in it first? No, it doesn't. Okay, carbon's not a metal. Okay, and hydrogen's only a metal if it's listed first. So this is a molecular compound. Those are the things you have to look at. Look at your possible identities here and go, okay, which one of these are ionic and which are molecular? Okay, then start figuring out some other properties that they might have. The easiest ones are the ones with colored metals. Okay, should be able to identify them pretty easily right off the bat. All right, so identify the easy ones, and then you can kind of work your way down towards others. Okay, there is also, if you want to double check to make sure that your data is correct, okay, on my website is the data for this lab. So in case you miss the lab or you lose your data, okay, or whatever else, okay, go to my website, go to Science 10, Notes and Assignments. Okay, and if you go in here, data and observations for labs, okay, you've got chemistry lesson 456, compounds lab data. If you open that up, there's a chart, okay, that should be like the one you were supposed to have drawn for today, ready, and it's got all of the observations in it in case you have any of yours that you don't trust, or in case you lose yours or whatever. All right, so you can go there, and that's where you can find, okay, the data for this lab. Now, and your analysis is fill this chart in, okay? Determine whether it's ionic or molecular and tell me what it is, okay? That's all there is to the analysis on this lab. When you get to the conclusion, in the conclusion, you need to restate your hypothesis. That's like essentially just copy and paste it, okay? Copy and paste it down into the conclusion. Then tell me, based on what you did in this lab, whether you can accept it or reject it. Don't just write, I was right. Okay? That'll get you 1 out of 4. Right? Restate your hypothesis and then tell me, were you able to identify everything? Did everything have unique physical properties? Okay? If that's the case, tell me that. Tell me how you know that. That's your justification for accepting, or if you didn't see that, rejecting your hypothesis. Does everyone follow on that? All right. For the evaluation, okay, in here, you need to identify any sources of error that you might have encountered. Okay, anything you thought might have interfered with your getting good data, as long as it's not human error. Okay, if you write in here, yeah, my group contaminated 3 samples, and then didn't do anything about it, here's what that says to me. We know we screwed up. We were too lazy to fix it. Yeah, not so good for you. Okay? That's not going to lead to a good mark for you, okay, on your lab. So don't write that. Okay, and if you screwed up, fix it. Okay, human error is not a source of error. All right, so you need, let's say, for sure 2 and how to fix them. Okay, for this. Everybody got it on that? You do not need to answer the class discussion questions. We will go over those when I hand back the labs. All right, everybody got me there? Now, I'm hoping that on Friday I can get one of the computer labs and I can show you again how you submit this stuff to me on Google Drive, how you use Google Drive, because remember, that is the only way I will accept your lab reports. Okay, so we'll go over how to do that on the Friday, okay, before the break. Now, this isn't due until after the break. Okay, it is going to be due on the Tuesday when we come back from the break. So you've got lots of time to get this done. If you wait till Monday night, Monday, February 24th, to do this, I don't feel sorry for you. Okay? And if something messes up because you've waited till the last minute, I will also not feel sorry for you. Okay? You have like 10 days to get this done. All right? Don't wait till day 9. Okay? Can you bring this into me between now and when it's due and have me look it over? Absolutely. Okay? If you want to share it with me on Google Drive prior to then, it's just come in and see me in scheduled help. Say, Mr. Kadir, can we look at my lab? No problem. Happy to do it. Okay? Happy to give you pointers. Couple of things I saw walking around today looking at your procedures. A lot of the procedures I saw are not detailed enough. Okay? Your procedure is out of 5 marks, and I want a very detailed procedure. Do this. When you're doing this test, this is what you're looking for in particular. Write it down. How much of everything are you using? All of that stuff. All of that should be included in there. Okay? Your procedure should be relatively long. All right? I'm looking for a very detailed procedure. I don't know. It should be, let's say, 9 or 10 steps, and they should all have a very good set of instructions on how to do them. Okay? And remember, you're not just identifying your variables, okay? You also want to explain your choices. So don't just say the manipulated variable is the unknown compounds. Tell me why it's the unknown compounds. By the way, that's the answer. Okay? So make sure that you write down an explanation as to why. Same for your responding, same for your controlled variables, 3 of them. All right, make sure you list 3 and explain all 3. Okay, easy ways to get marks, guys. If you do what I tell you here, okay, the marks are easy. If you don't do what I tell you, the marking's easy for me. Okay, I just don't have to give away as many marks then. All right, I want to give you as many marks as possible. Make sure you do what you're told to do. All right, questions on any of that? All right, you got 5 more minutes to talk to your group mates, okay, about what you think some of those compounds might have been. I would also mention that Google might be a good way to figure out, in case you can't figure it out. You might try Googling properties of this compound and seeing if any of them match. Worth a try.